Computer storage is one of the important parts of what a computer does. Okay, it's one of the important parts of what a computer does. But now let us look at this lesson. Now, in this lesson, we need to get the following expectations. We need to get the introduction, the types of storage, the primary storage, and secondary storage. Okay, these will be expectations in this lesson. Now, looking at the introductions are very, very important. And from these introductions, we normally get extra from whatever, compared to whatever we have in our books. Okay, so now in the introduction, how storage devices come about is after the computer has finished doing something. Remember, we said the computer has to first process certain inputs. The input we put in the computer is what we call data, and this data is going to be processed by what we call the CPU for output. The outputs and the input devices, we have already looked at them, but today our focus is storage. Now, after the computer processes this information, it has to store this information somewhere for future reference. Remember, in the very first lesson you had, in your very first computer lesson, they asked you about what a computer is. And we knew that we actually said that a computer is an electrical device that accepts inputs, processes those inputs, okay? After processing the inputs, it can output it or store it for future reference, okay? That is what a computer. So basically, when we are looking at the input devices, the processing devices, the output devices, and storage devices, we are looking at the hardware of the computer in relation to what the computer actually does, because the computer can't do what it's doing without the hardware devices, okay? All right, now the storage comes in after the computer has processed and has decided to store this information for future reference. Now, that will be that for the introductory part. Now, we have to look at computer storage. Now, members, right now we are all using computer storage. You are all using your phones because there is somewhere the programs you're running on your phones have been loaded. Some of you are using flash disks in your computers. Some of you use magnetic tapes still. There are CDs, there's a hard disk, floppy disk, micro memory cards, and so on. Okay, so we are using these computer storage devices in our daily lives. Okay, for example, right now all our computers on which we are attending these lessons have what we call the hard disk. We're talking about the laptops and the desktops. The devices we're using right now also contain what we call the RAM. So we also have what we call the ROM. Some of us watch videos when we buy CDs and we insert them in the CD players. We watch those videos on CDs. The floppy disks have been there. Some are we even still have them, though they are rare. These were used those days for storage. They are in smaller sizes, but we are going to look at these devices one at a time. Okay, one by one, we shall get to know them. Even the memory card, we use memory cards in our phones. Some of us have button phones at home that cannot work or cannot take a pic without a memory card. So we need a memory card to take a pic in some button phones, okay? We have a pen drive. Don't be confused of the name pen drive. The pen drive is just the same. It's just the same as saying a flash disk, okay? Some of you call them flash disks, others call them pen drives, okay? Then we also have the magnetic tape. Someone is asking whether the tapes are still there. The tapes are still there. You know, there are certain people who like to stay ancient, okay? Because they enjoy being where they are. They don't understand our technologies right now. It is you students who are lucky enough to actually get the chance to learn how to use these technologies. Otherwise, if you are not going to school, it would be hard for you to actually know how to use these latest technologies like the flash disk and the CDs. But because we have learned and we are always evolving, now these ones are also phasing out. But still you can find them. People still use them. There are devices, radios, which are very strong enough that They have lasted for over 20 years and they're still working and they're using the magnetic tapes. So we are going to look at these computer storage devices and we shall understand them into details. Now, let's look at the types of storage. Members, computer storage devices come in two types, and these types depend on how the computer actually stores information on that device. Okay, someone is asking a question. Okay, yeah, it depends on how the computer displays information. The computer stores information on those devices. Okay, now when you look at the temporary RAM, the temporary storage is a type of storage in which storage is temporary. Just from the name, the storage there is temporary, meaning when power goes off and your machine also goes, or when power in your computer goes, the memory also loses its content. Okay, the examples we shall look at them, but the common example we shall look at is the RAM. Okay, so the RAM is an example of a temporary storage, but we are going to look at these storage devices into details. Okay, so the temporary storage devices, we say, have the ability of a computer to only store data for a short time as long as the computer is still on. Are we together? Then, of course, we also have the permanent storage. Now, these ones have the ability of the computer to store data or information on a permanent computer storage medium. Okay? Okay? So, okay. Now, the storage is also known as a backing storage or a secondary storage. That's what you should know. Some people, you call it a backing storage. Now, in this type of storage devices, the permanent storage devices, if you don't delete the data or the information from it, the information will stay there. Then sometimes you also have to just delete. You don't just have to delete, because when you delete, some people think you are deleting permanently, but no, you are not deleting permanently. We have to delete permanently to completely lose certain information or data from these storage devices, the permanent storage devices. If you don't delete permanently, you can always recover it from what we call the recycle bin on our computers. Okay, so we have to understand that these are the two types of storage devices we are going to look at. Of course, the examples of these permanent storage devices include the hard disks and what we know as the USB flash disks, and so on and so on. Okay, now let's look at memory. We said these devices need memory in order for them to contain the data they're supposed to contain. In order for them to store, they have to contain certain amount of memory space to store this information. Now, we have to understand memory. Computer memory is normally divided into two. There's primary memory and secondary memory. This is just a diagram for you to understand, okay? Now, this diagram will help you understand how the computer actually manipulates its memory. So the memory is divided into primary and secondary. Okay, Francis, please unmute and ask your question. I see your hand is up, Francis. All right, I think he was just, I don't know. Okay, please use the reactions when you actually have something.
Excuse me, sir.
Okay.
Excuse me, sir.
Yes, please.
Yes, sir. You have given us as the types of storage as temporary and permanent storage. Now, which type of question will be there? How will they phrase a question where they'll be asking us to list the primary and secondary storage?
Okay, you shouldn't worry about which questions are coming. You see, when you're answering exams, you have to understand what they need from you. Meaning, you'll answer a question depending on how you organized or how you prepared for the exam. Okay, so if you prepared for the exam, there's no way a question will defeat you to answer. Of course, several questions can come from just this slide alone and from whatever I've said. I can ask you for an example of a temporary storage. Okay, I can ask you for an example of a permanent storage. I can also tell you to give me the two main types of computer storage devices. So you'll have to know that they are temporary storage and permanent storage. But in order for you to answer a question, you must always prepare to answer questions. Okay, so when you're prepared, trust me, there'll be no way you'll fail to answer any question. Okay, so don't be scared. Okay, just make sure you understand. Okay, so like I was still explaining, the computer memory is divided into primary and secondary. The computer memory. In other words, the primary is depicting the kind of memory we find in primary computer storage devices. Then the secondary type is what we find in secondary storage devices. So further, when we look at the primary memory, it is divided into two, what we call volatile and non-volatile. Okay, what we call volatile and non-volatile memory. Now, when we talk about volatile, it means it is memory which is going to be lost when power in the computer goes off. Okay, the examples include the RAM. Okay, and the RAM is further divided into two types: the SRAM, which stands for static RAM, and then we also have the DRAM, which stands for the dynamic RAM. Okay, and then of course the other part is the non-volatile. Non-volatile is the opposite of volatile. If volatile means information or data is going to be lost immediately when power goes off, then non-volatile is the opposite. Information won't be lost. The information there is going to stay unless you remove it. Okay, then the example there we see is what we call the ROM, or what we know as the read-only memory, which will be divided further into what we call the PROM, the EPROM, and the EEPROM. Don't be scared of these terminologies or these abbreviations. We are going to look at them as we continue. Okay, then we also have the other side, of course, of the computer memory, the secondary. Here we have three types. It's divided into three types. We have the magnetic storage. Under the magnetic storage, we have the HDD, floppy disk, magnetic tape. Now, when you look at these examples, the hard disk, the floppy disk, and the magnetic tapes, you will actually notice that these devices have something in common. The thing they have in common is a magnetic substance, a magnetic surface onto which information is going to be stored. When you open a magnetic tape, there's that thing that looks like a rope. It is, most of you have seen, almost all of you, in fact, all of you have seen a magnetic tape at least. You'll see that inside that there's that rope onto which the information is going to be written. So all of them have such a surface. In the hard disk, when you open the hard disk, you'll see a surface. When you open the floppy disk, you'll see the surface. Now, if time allows us, we are looking at this, I will show you inside how the HDD or the hard disk or the floppy disk or the magnetic tape looks like. Okay. Then we also have the optical storage. Now, the optical storage uses light to store information onto itself. For example, the CDs, the DVDs, the Blu-ray. These are CDs and DVDs you use at home for watching, but you should understand how they work. Okay, they use the light technology. The information is written onto them through exposing them to laser light. Okay, the laser light is going to be generated from within the computer drive. Then we have the flash storage. Here we look at the pen drive and the memory cards. I told you the pen drive is the same as a flash disk. Okay. All right, that is an introduction to the computer memory. Okay, Francis, please unmute and ask your question. Yes, Francis.
Sir, yes. The difference between the primary and secondary storage systems is that the RAM and ROM are found inside the computer, and the ones like CD, DVD are just inserted in the computer, and they can remove information, and while and ROM are built into the computer. Is that their major difference?
Yeah, that can be their major difference, because when you look at these other devices, you'll see that they are all external. Okay, though it's not the case, because we also have the hard disk inside our computer. Okay, though we have external hard disks, but it's okay to say that the secondary devices are the ones which are outside the computer. It's okay, you can say that. Okay. You can understand it that way. Because the primary memory storage devices, the primary storage devices will always be inside the computer. Okay. Meanwhile, the secondary can be outside, because when you look at the pen drive, the memory card, the CD, the floppy disk, magnetic tape, these ones are external. Okay? Yeah, it's okay, Francis, to understand it that way.
Okay.
All right, all right. I appreciate that.
Okay.
I appreciate that you're really following up, and the questions you're asking are relevant. Okay, so thank you for that. All right, let's continue. Now, moving on to the next slide, members. We're going to look at now that diagram we just looked at. This diagram here, we are going to look at it one by one, understanding how the computer memory actually works, okay? Starting with what we call the primary memory. So we say the primary storage is also called the main storage, okay? It's the main storage or the main memory or the internal storage. Just like Francis was asking, they are internal, okay? They hold all the instructions and data needed for processing temporarily. That's why we call them primary memory, okay? So they are an example of the temporary ones, okay? Now, they hold instructions and the data needed for the processing temporarily, meaning information can easily be lost. All these instructions can be lost when the computer is not on or when power goes off, okay? Now, let's look at the random access memory, or what we also consider as the RAM. Okay, now the RAM is one of the most important components. One of the most important components we find in the computer. Okay, now the random access memory is the memory which holds the software and other input data while the computer is working. Quote me right, I've said it is the memory which holds the software and other input data while the computer is still working. What does this mean? When the computer is off, does it mean that the RAM will have some memory, some software or other input data in it? No. When the computer is off, the RAM is not having data. When it's on, that is, or when you are trying to run a program, that is when the information or the processes or the instructions will be loaded onto the RAM. Now, most of you are probably asking how the RAM looks like. I already showed it to you. This is how the RAM looks like, okay? This is a computer RAM chip. This is how it actually looks like. In the future, I know you will see how they look like. Now, let's look at the characteristics of RAM, of the random access memory. Okay, why do we call it a RAM? Or what makes it to be called a RAM? First of all, we look at its functionality. We say it's volatile, and therefore it can lose its content when the computer is off. Okay, when the computer is off, when the computer is switched off. Edwin, please unmute and ask your question. Edwin, please unmute and ask your question. Edwin, do you have a question? Okay, it seems Edwin doesn't have anything to say. Let's move on. The first characteristic we look at is what we call the volatile, okay, of RAM. It's volatile, meaning it loses its content after the computer is switched off. Now, it will only contain something when you're trying to run a program or when you're starting the computer. Because when you're starting the computer, you're actually loading the operating system from the internal hard disk, okay, onto the RAM. So for as long as the computer is on, the RAM is going to have some data, okay? Now, the other characteristic is it is read, copied, wrote, altered, and deleted. Meaning you can put information in it, you can also remove the information, you can actually copy information which is still in it, and you can also copy it somewhere. For example, if you're running a Microsoft Office Word application and you're typing work, okay, that application at the beginning when you are running it, it's going to be loaded onto the RAM. Because I say the RAM will only contain content after we have loaded something onto it or we have started running a program. So you will load this application all together onto the RAM, and as you're working, you're actually working from the RAM. Now, what does it mean to read? Reading means you're able to see something which has been loaded onto the RAM, but you're able to output it for you to view, okay? From the RAM itself, because the RAM is now the one possessing this information, okay? Now, the copied means when something is running, for example, you can copy something from the word processor you're running right now, which is on RAM, and you can copy and paste it somewhere. So the pasting is what we call writing. Okay, so whatever is in the RAM can be read, copied, wrote, altered, and even deleted. Okay, then also the other characteristic is the amount of data it can hold at a given time is highly limited. Okay, the amount of data it can hold at a given time is highly limited. That's why when you buy a computer has about 4 GB RAM, about 2 GB RAM, or 8 GB RAM. Some even have 16 GB RAM. But fortunately enough, when we're buying laptops or even computers, we have what we call expansion slots. These slots allow us to increase the RAM or increase the capacity of RAM at a given time by adding more chips or by inserting more chips into these expansion slots. Okay, so these expansion slots give us the ability to increase RAM. What some people say, my RAM has 16, and yet inside the person has, inside the computer has 2 slots, each holding 8 GB RAM chips. Okay, that is how people say I've increased the RAM. Now, if the 16 is not enough, I can buy a 16 chip and I put it in the place of 8. I also remove the other 8. I add another 16. I have 32 GB RAM. So there's the capacity of RAM is kind of limited. Meaning, when you're running a program, not all the program is loaded onto the RAM as a whole. Only part of it processes that allow, or certain small programs that allow this program you're trying to run are the ones which are loaded onto the RAM. Then we also have to know that it is expensive compared to ROM. So the ROM is cheaper. The RAM is expensive compared to the ROM, the read-only memory. We are going to look at the ROM. Don't worry about that, okay? Then physically, it is a chip, just like I showed you in this previous image here. I'll show it to you again. Physically, it is a chip. It is a chip like this one, physically. Okay, like this, the one I'm showing you here, that is how the RAM looks like. It's also a characteristic. Its appearance is a characteristic, okay, which has storage capacities in MBs, in GBs, or even in TBs, okay, depending. So we have the 64 MBs, we have 2 GB, we have 8 GB, we have 4 GB. There are so many in the market, okay? So those are the characteristics of RAM. Now let's look at the types of RAM. We have 2 main types of RAM. One called the DRAM, which looks like this, and then the other which is called the SRAM. Now, DRAM, I hope you are taking notes. I always want my students to take notes of whatever I say, because sometimes I say a lot. Some things even are not there in the notes. So it is okay for you to take some little notes. Then there are also times I don't say some things, but you can always ask the questions either directly to me, or you can ask our head of department from the chat section. He's always there. He's always supporting us, okay? I am very happy that he's always there to help us in our lessons running smoothly. So he's of a very big help to us. Ask your questions, so long as they're relevant, he will answer them. You'll find that when your questions are not relevant, he doesn't even speak. He's just there. He doesn't do anything. But when they are relevant questions, he answers them. So don't hesitate to ask questions when you don't understand something, so long as the questions are relevant, okay? So starting with what we call the DRAM. The DRAM is an acronym for the Dynamic Random Access Memory, okay? It is Dynamic Random Access Memory. I see a lot of, okay, why is the RAM more expensive than the ROM? Now, Emmanuel, I told you should ask relevant questions. Now, I would ask you the same question. Why is your shoes more expensive than my shoes? Okay, so you should ask relevant questions, please, members. Let's not ask questions which bring other things. Okay, so always ask the right questions. So the dynamic RAM is a type of RAM we must understand that stores information dynamically. Okay, the information is stored dynamically. Information in it is stored in blocks. Okay, it is stored in blocks. Now, the example is the RAM chip we see. Whatever we use in our computers is what we call the DRAM, they're dynamic. Then we also have the SRAM. Okay, the SRAM is what stands for static RAM, or static random access memory. Okay, now the static RAM is static and opposite to dynamic. Okay, you can even see it is normally embedded onto the motherboard. Now the motherboard is that grainy surface you see onto which this has been embedded. So it is static, and information there is stored in is stored, but it is stuck onto the motherboard. Okay. Now to get more information about the dynamic RAM and the SRAM, I think you'll have to visit the internet, because we have information, though information on the internet is not 100% correct. You have to know how to get the right information. So you'll get more information about the DRAM and the SRAM. But what we have is the DRAMs are the ones we normally use in our computers. When there are other computers, especially the very old computers, we use the static RAM. Okay, all right. Okay, now let's move on to what we call spooling. The word sounds nice, but it will be unfortunate if you don't know how a nice word like this one means. Okay, I'm seeing. Okay, Wycliffe, please unmute and ask your question.
What of the VRAM?
Pardon? What of the?
Excuse me, sir.
Yes, please.
What of the VRAM?
What of VRAM? The VRAM? The VRAM is what we call the video RAM. Okay, video RAM. It's the one in charge of processing video or graphics. Okay, now we are going to look at them. Don't worry, we are going to come there. Those things you're asking are ahead. Okay, we shall look at all of them. We're even going to look at virtual memory and so on. So don't worry, let's move one at a let's keep our pace. Okay, don't worry, you'll know these things by the end of the lesson. Okay, all right, you can lower your hand, or let me lower it for you. All right, now let's continue. Spooling. What does spooling mean? Now, members, sometimes we need to transfer information from our flash disk to the computer. Sometimes we need to print work from one computer, from our computer on the printer. Okay, that is where the word spooling comes in play. Now, the process of us transferring data from one storage media to another is what we call spooling. Okay, it is what we call spooling. When we transfer data from your flash disk to the hard disk of your computer, that is spooling. So without the data spooling, members, data from input devices would be stored in the primary memory, making it overloaded. So some information has to be transferred. Even when we are loading information from the central processing unit, when you're running Word, certain programs have to be sent to the RAM. Okay, now even that process of transferring those programs to the RAM is also what we call spooling. So long as information or data is being transferred from one storage media to another, it is spooling. Now here is a diagram just to show you how spooling actually works. Now we see we have a spool disk. Okay, then we have the CPU, we have the storage, secondary storage, and the line printer. Now here we have the secondary storage. Our secondary storage can be a flash disk. When you insert a flash disk into your computer and you're trying to transfer information from the flash disk to a spool disk, which in this case would be our RAM or even our internal hard disk, the information you're trying to share or the information you're trying to transmit has to pass through what we call the CPU, which is the brain of the computer. The CPU has to process everything before it happens. It has to be aware. So every kind of interaction, every kind of operation must be known to the CPU before it actually resumes its operations. So when I'm transferring, the CPU processes the information that the secondary device, this wants to send some data from there to the spool disk. It processes it, information is going. So this process, this arrow from the secondary storage depicting how information is moving is what we call spooling. We also see spooling when the information is being transferred from the spool disk to the CPU, probably the cache memory of the CPU. Okay. Then we also have spooling when we're looking at the line printers, because printers have what we call temporary storages called buffers. Before you actually print, information is going to be stored on the buffer of the printer. That is why sometimes when you come to print after someone has just printed and the process he didn't print actually, because probably there are no papers, then you come back to want to print some other work of yours. When you print, it will not print your work first. It will first print the work which is still there in the buffer. So how do you prevent that problem? You first go and clear the buffer before you actually print your work. Okay. Or an example could be if we have two computers which are connected to the same printer by networking them. If both computers send a printing job to the printer, in order for the printer to print, the printer has to know which job was sent first. It makes use of time lapse. Okay. Which instruction came first? Which computers are requested for printing first? So when it identifies that, it prints, it stores the other one in the buffer. So that is how the spooling works. Okay. So we also look at now the read-only memory. Okay, we have what we call read-only memory, which is also an acronym. We use this for ROM. Now, a computer has a built-up set of instructions. Okay, they are built-up set of instructions. They're just built up there so that when the computer is starting, the instructions are loaded and executed. Okay, these instructions are non-volatile, meaning they can't be lost. So it is an example of a primary memory because they are still internal. The ROM is still internal, and it is the opposite of the RAM. RAM is volatile, ROM is non-volatile. So it has to know what to do when switched on. And those instructions are resident on the RAM, okay? So it has those instructions which are written there, okay? Now, the ROM actually, it's not a must that the instructions are supposed to be there permanently. Though they are originally, when the ROM was first introduced there, they were supposed to store permanently because the very old ROM would store the information permanently. But as computers keep on advancing in technology, people actually now were able to even alter whatever is on the ROM. They are able to erase whatever is on the ROM. Okay, but the idea is the instructions in the ROM are supposed to be stored permanently until you do something to them. So the computers can read or follow the instructions in the ROM, but they cannot change them for a type of ROM. Okay, it is the computer which can't change them. Okay, but these can be changed by certain programmers, as we shall look at examples when we look at the examples of the ROM in the next slide. Okay. Okay, so now normally a good example of this ROM, how we can see this ROM is when we are switching on the computer and the process called the post, the power on self-test, where the computer has to test whether each function, each component is working well or not in terms of power and so on. Those instructions are loaded from the ROM. To do that kind of test, it is loaded from the ROM. So the computer, when it's starting, the power on self, it initializes the computer when the power is turned on before you start, okay? When you start the computer by turning on power, the power on self-test is going to be executed. But these instructions to perform this operation are kept on the ROM, okay? So the ROM is meant for such kind of instructions. Meanwhile, for the RAM, every other program we run is going to be loaded on the RAM temporarily. That's why we call it volatile, and then it will be lost when the computer is off. Okay, so let's move and look at the characteristics of ROM. Okay, we have the characteristics of ROM. First of all, we know it's non-volatile, meaning it does not lose content when power is switched off. Okay, the information is always there until a programmer who comes to change it. Okay, then we also have the computer cannot write to it, therefore programs or contents cannot be changed. Though this is supposed to be for a specific type of ROM, because there are programmers now who can change the content on the ROM. Okay, so you can say for all the ROM, for the P-ROM, okay, the P-ROM, the content cannot be changed. You can specify it in that one. Then it is cheaper compared to the random access memory. Okay, someone was asking why is it cheaper? Because okay, the answer I could give to you for that question is that the ROM will always be there. Every computer comes with the ROM, but the RAM because it is a chip and we can always change it, you'll find that people tend to buy it even after buying the computer. Okay, when you need more RAM, you have to buy. But the random access memory is always there because every computer comes with it. First of all, the instructions for the computers to start are kept there. Okay, so those are some of the characteristics of the ROM. Now, let's look at subsets of the ROM, or what does the ROM, the types of ROM. Now, we looked at in the diagram, we said there was example, there was a type of ROM called the P-ROM. Now, I've underlined the word P because it is where the changes will be coming. You'll see the next one has EP underlined and then EEP underlined. Now, the P is what stands for programmable read-only memory. Now, this type of memory can are first written to it and will never be changed. Okay, the information on this PROM will never be changed. Okay, then the EPROM is standing for erasable, programmable, read only. Now, when they say programmable, meaning here we make use of programmers, people who write the instructions, people who write the code, people who will become, some of you people will become these programmers in the future. You'll be the people who will be changing this information on the ROM, okay, or to program the information on the RAM. So the first type, you can program the information or the instructions, put them there and they stay there permanently. You can't erase them, okay? Normally, they are done, these instructions are written during the production of these computers, okay? Then the EPROM, the E stands for erasable, then P, programmable. Now, the EPROM, read-only memory, can be erased, okay? It can be erased by the programmers, okay? Then the information can be rewritten. Are we together? The information can be rewritten, all the instructions on the ROM can be rewritten by the programmers, okay? Then the EEPROM stands for electrically erasable, programmable, read-only memory. Now here, in this type, we use electrical signals to erase the instructions on the computer for rewriting. So you'll see in the last two types, information can be rewritten through certain processes. Now, I'll stop here because our time is almost done. The next lesson we have will start from where we have stopped, where we shall look at other options of memory. I thank you all for attending. Please have a good day.